This is Niko. I'm not even going to try to pronounce Niko's last name. Niko is infamous around the world for his expertise on Columnstore indexes, but of course, now he's going to share that knowledge with you. So, Niko, take it away.
All right, ladies and gentlemen, and everybody who's watching this recording, welcome to the session on the Columnstore Indexes, worst practices, and less known limitation. Not unknown, less known. This will not be a very basic session. I'm sorry for that. I will not do a really explanation. I will try to just like try to dive into this stuff. If you are missing the concepts, feel free to rewatch the recording. There are great blogs. There is a very nice series written by Hugo Cornelis on SQL Server Central on the Columnstore Indexes. Sunil Agarwal, the principal program manager who led the 2016 release of the Columnstore Indexes, has a huge number of blog posts on the Columnstore Indexes. There are presentations and so on. Go and learn this stuff. If you feel like, you know, I'm talking absolutely gibberish, that's not your fault. I'm Portuguese. I'm crazy. I'm not even sorry. All right, so let's dive into this stuff. So my name is Niko Neugebauer. Don't try to pronounce my last name as Brent just mentioned. I'm describe myself as a Microsoft Data Platform professional. It means I like working with different aspects of Microsoft Data Platform. I work for a great company which is called OH22. And so on and so forth. So you can see all these details. I run a couple of user groups locally in Portugal, organize a couple of events, blah, blah, not interesting. I blog quite a lot on the Columnstore Indexes. I have over 100 blog posts. Every month I do like 3, 4 new, and check out the CISL, Columnstore Indexes script library. This is a library which you can use to discover the insights and some of the internals and do the optimizations of the Columnstore indexes. Free library, GitHub, use it, do it whatever you want. I'm fine with it. Don't blame me. Okay, you can if you wish. Who cares? So today's agenda is very simple. I have like 6, 7, whatever slides, and then we just examples, nothing else. So intro, overall recommendation. Building Columnstore indexes, quite important, this stuff. Building and rebuilding. So loading data into Columnstore indexes, very important. I've seen cases of a row store process running in few minutes, 15, 20 minutes, going, changing to Columnstore and running over 5 hours, which drove the client absolutely nuts on the next morning because, of course, it broke a couple of things. So loading is really, really important because you can load the data into the Columnstore indexes faster than into the row store. Querying the Columnstore indexes. Well, once you get the data into the Columnstore, you want to extract the data. You want to get some insight. That's not about artificial intelligence. That's what I have. I have an artificial intelligence. Nobody knows. But let's go into the Columnstore index. Columnstore indexes are, and that's the only basic slide I've got. They are vertically separated. So I used to say, this is how the non-IT people used to think how the databases are storing indexes, because people like, they look at the Excel and they see like the columns and they say like, this is how you store that in computers. And now you can say with the Columnstore indexes, yes, this is how we do it. So they are grouped into the segments. So these segments, they can contain between 1 and 1,048,576 rows. Not 1 million rows, because you can and you will have a very small row groups. But these are a kind of a partitioning. So you have the huge amount of data on the image. You can see I have like 3 row groups. And let's say you have 3 million rows. You will have at least 3 row groups. Let's say everything went fine. We got no memory repression, no dictionary repression, no other limitations. We've got every row group with 1 million row. And segment corresponds to one column's row group. So for me, column C1 is split into 3 segments. One segment for each of the horizontal row group, and it contains the values for the rows of these 1 million rows, hopefully, and just the values of the C1 column. They're extremely compressed. So once you are migrating from the heap table, non-compressed, completely non-compressed table into the column store, what I tell to my clients, expectation is you'll get around 10x improvements. This is what I've seen. I have seen over 100 times. Let's put it this way. This will depend hugely on your data. If you Google, I've also written a couple of blog posts on how Columnstore Indexes compresses, how they achieve this. Extremely compressed. If you compare with the page compression, the best available row store traditional indexes compression, you can expect 2-3 times. Your mileage will vary because it will depend on the quality of the data. And they're tuned for processing large volumes of data. So like, I've got a big data, I've got 50,000 rows. No, sir. You've got 50,000 rows. That's a rather small dimension in data warehousing. It's okay, you can put the Columnstore indexes, they can bring you some significant advantages, but it might not happen. They're thought for the millions, billions, and gazillions of rows. And I told you this, you already know it, so let's dive into the real stuff. So back to the agenda again. Overall, the highest seen once, especially you migrating to 2016, and the same will apply to the RTM and the future versions as expected of the SQL Server. If you do not use the highest availability compatibility level, you will be removing some of the most advanced Columnstore Indexes batch processing mode functionalities. And it will do a huge, and I can tell you that every single week I receive emails, people, basically that's this, they do the migration and they don't see like the advanced functionalities bringing them these advantages. What is going on? And like, check your compatibility level. Might be the thing. What about the building? Cutting on memory. Just like get the biggest amount of memory you can get. Scream at your DBAs. Scream at your managers. Cry like a baby. I don't care. Do something. Get some more memory. When you are rebuilding Columnstore indexes, one of the most important things will be resource governor. Do not put a rebuild of the Columnstore indexes to compete for the resources with row store processes. You will not like what you will see. Do not even put outer index reorganize, the tuple mover, into the same situation. Never. Just I can tell you in the future there will be more information on this stuff, definitely. But right now I have found out at SQL Beats that some of the problems that take place on some of the machines I have avoided just by using this practice, which I said a couple of years ago for myself. So that's an important one. Don't use strings. Well, if you can avoid strings, they are evil. Strings are evil for the Columnstore indexes. 2016 has improved enough stuff, but still they're so evil. And if you're using, go ahead.
There's one of the Oleg asks, how about GUIDs? Are GUIDs considered strings, or are they, or is it okay to put GUIDs in Columnstore?
Not a very good idea, because GUIDs are very, very fast. And most probably you will get a lot of problems. I would expect instantly the dictionary problem on the GUIDs, which is not solvable at all right now currently. All right, so partitioning. If you should be absolutely using partitioning. If you're 2016 Service Pack 1, there is no reason you can't use partitioning, right? And it's not like just because we can, we should do this. No, it's not about that. So there are scenarios, and I'll show you the demo, when over-partitioning can bring the column store indexes on its knees, virtually on its knees. Not a very good thing. Compression delay. Just a small feature, but can irritate and piss off badly people. Just you need to check on it. What about the loading? Not using bulk load API. So if you are loading less than 100, 2,400 rows at a time, your data will land not into the compressed segments beautifully, it will land into the delta store. In 2014, these delta store are page compressed. On 2016, very important improvement. They are not compressed anymore, but they will land there. Very, very slow process. Very, very slow. So basic recommendation here is group. If you're loading into data warehousing huge amount of data, just group it, just pre-sort it on the most important column, and then load it. It will be beautiful. Using identity. Not a good idea. Using merge, evil. Parallel loading. You need to be using parallel loading in 2016. Amazing feature. I don't know why Microsoft even blogged about it so late. Like they took, after somebody mentioned it publicly, I blogged about it. It took like 6-7 months for them to blog, to force Neil to put a blog post on this. This is huge thing in 2016, and you need to use this. So a couple of things on integration services. A couple, because there are no many news in integration services 2016. Oops, I said it. And then we have something about the querying. So casting on the wrong side, which is not the east side or west side, it's the wrong side. Overusing null expressions. I know that Brent, he loves nulls. He just, his life is like, he's getting better when there are nulls. Focusing on cross apply where it's not needed. Don't use. I mean, if you need to use it, if there are good reasons, go for it. But be aware what it might bring to you. Not using the advanced storage engine features. This is like a bad thing. And one of the most cardinal sins is not believing that the estimate and the actual, they can be very, very different. And for the column store indexes, they can be absolutely different. I'm not talking about the adaptive query processing in 2017, which is bringing like another, oh, yeah, got it. Is not null.
I couldn't fit, and I tried that. I wanted like longer things on the license plate or nullable. No, not nullable. No, it didn't work. Yeah.
That's beautiful, sir. So estimate are not, do not compare the estimates for the column store indexes. This can lead you to the wrong path for the performance evaluation. And well, it's just a short mention, just don't use natively compiled store procedures when you have the in-memory column store indexes. They will not be used. That's bad. And you will not be able to see it. SQL, the Lone Star, the Texas style. Sir, yes, sir, with honors. And so that's it. That slides are gone. Niko's going down to the management studio, hopefully. All right. And so I have a couple of demos. So basically, this is what I prepare. There's like 13 different folders. Each one has, some of them have over 10 scripts. That's absolutely crazy. We wouldn't fit it into 2 hours, and we'll try it anyway. Let's do this. I'm just like enjoying myself. I don't care. Unless Brent shuts me down, I'm doing my 60, 70-minute hours, and Cavallo Marotto will take over, and the data monster will be showing you a blue tongue. Scary stuff, people. All right. So what I have here is a very, very beautiful 2016 SQL Server. with the service pack 1, I know, can be very evil without the latest cumulative update. Cumulative update 2 has fixed 9 very bad bugs. So use the latest cumulative updates for the column store, just a little tip. And I have here a couple of databases. First of all, I have the infamous, or famously famous, or 3,000 times famous Contoso Retail Data Warehouse database, which didn't change since brand 2008, 9, probably 2010. Let's be, respectful of the old databases, And I also got TPCH database. What is a TPCH? These are a kind of a data warehousing schema, kind of snowflake thing, comparable. And how can you get one? Because I will not give you mine. I'm bad. There is something which is called HammerDB. It's a free stuff. There are many people. I believe Kevin Klein, Kendra Little, a blog, published videos. So many people talked about this. Google it, find it, install it, generate your database. You can go into terabytes, right? The latest version, they generate Columnstore Indexes by default. Smart people. All right. Okay. So let's run a couple of things on my Contoso Retail Data Warehouse database. So I will go to it and I will set the compatibility level to 130. The compatibility level directly can be set through right-clicking on the database, selecting the properties, going into the options, and selecting the right compatibility level. This is what you want to have on 2016. When you do upgrade, when you use the query store, all these techniques to keep your execution plans correct, well upgraded, this is all the same stuff that everybody told you before. I'm talking, this is your goal. This is where you will get the performance improvements. All right? So I have it on 130. I will set the statistics time IOO, and I'll run a simple query doing a fact online sales table join with the dimension of the product, doing a small filter aggregate, and it takes me, well, let's say 586 milliseconds, very slow. Fact online sales table has 12.6 million rows, so it's half a second, all right? In my case, 2 cores. Let me just show you that the fact online sales, I'm not showing you the actual execution plan right now, but it's got this beautiful clustered and at the same time Columnstore Index, right? Okay, so let's run the same query on the 120 compatibility level. Let's see what happens. How will it work? Well, that's a similar time, and actually it's even a little bit faster. That's incredible. Well, are you saying, Niko, that I'm doing downgrade? No, it's an average time, because sometimes I consider it to be similar. Okay, sometimes you'll get one faster, sometimes other. Maybe I'm running some workload in parallel, I don't know, whatever. So let's run this query on 120 on 2014 compatibility level. I'm just going from 2 DOP, from 2 cores into 1 core. What time did it took? Woohoo! Ladies and gentlemen, we burned our CPU. That's a little bit slower. Like, slower how? Wow. Like, that's like almost 10 times slower? Wow. Niko, what did you do? Well, that's 2014. What if we do an upgrade to 2016? So compatibility level back. Let's rerun this query. How much time will it take? Oh gosh, that's not 5 seconds. That's 1.5 times slower. This is what you would expect. The thing is, this is the biggest fix Microsoft did. This was a huge pain in the back in 2014, 2012. Batch execution mode runs only when you have 2 cores or more. And 2016, on 2016, if your compatibility level 120, you're still not getting it. And that will drive people crazy. It's like, it's not faster. Check your compatibility level. All right. And I have a query which is using a not very much documented or supported trace flag, but which will basically put this execution plan into the raw execution mode on 2016. And you can see that I have a similar execution time with the compatibility level. So it's all only about the batch execution mode. And on one core, you can get it only with 2016 compatibility level. On 2 days ago, announced 2017, there will be stuff like this, definitely. So just keep in mind this, be aware. Sorting, this is one huge improvement. No matter what people will say, windowing functions are beautiful. The most of the time the execution plan is spending is doing sorting the data. If you don't get the sorting right, it will be small. This was Kavalu Maroto who said this, you know, I was not talking. So the same thing, I'm not running the demos because I want to spare, because I have too much stuff. You'll have to trust me. I know it's tough. You got to do this.
A couple people asked if are they going to get the scripts too? Are they like on your website?
Never.
Okay,
I'm not
good
sharing.
answer.
It's just like ever. Brent, I'm sending them not right. So I finished the session, but tonight.
Light them on fire. There you go. Oh yeah, sure.
Yeah. Winning all the time. So 130 compatibility level. I'm running a basic aggregation predicate push down. Okay. And it took me whatever time it took. So this is 4 milliseconds, 4 milliseconds. This is 12.6 million rows, ladies and gentlemen. 4 milliseconds of getting max, not bad. Okay, let's do it the old style, 2014. That's not milliseconds, I guess. Not very much milli, not very much 2.4 seconds. 2016 is not faster. Did you ever check the compatibility level? I warn you, that's not going to, you know, I tried. I talked to the psychologist, my wife, she tried best. She said, like, in your case, Niko, sorry.
The best you can do is just get on webcasts. Yeah.
Bingo! Brent Lazar, Partitioning conference. This is how we're rolling. All right. So compatibility level is important. Another one is memory pressure. So here is a script. You'll get it. You can run it. Don't run it on a production, please. So I create something Evo, a resource pool which is called raw memory with a max memory percent on 20 set, and then a greedy workload group which is using just just 5% of those 20. And we run the reconfigure. We go to create the classifier function and say if Niko is entering with Niko sudo, then you use the greedy pool. And let's do this system maintenance. So I already rebuild my Columnstore Index, fact online sales, and you can see that I have here on fact online sales, it's well, whatever, it's not filtering very much, but I have 13 row groups. Okay, the maximum row here you can see is number 30, and then it goes on to the other tables. I can use my CISL function, which I always use, and it will get me a little bit more complete information and so on and so forth. I can see I only got the compressed row groups, and it's 13, and it's 12.6 million rows over there. This is all the information. Oof, wrong button, Niko. Wrong button. My
it's always hard to remember those.
Yeah, my Zoom foo is not the professional one. So let's do this. Let's do something evil. I'll do this, and I will enter as a Niko slow, and I will run the rebuild on the right database. You gotta be aware. So I create on the wrong database. most of your queries will be blazingly fast.
I like to demo that
as
as this is how security works. Mm-hmm. Oh, while you're in there, Elsimer asks, would that the max stop stuff, does this still hold true if we're using the legacy cardinality estimator from a query hint? Do we get slowed down if we're using a query hint for a legacy CE?
I don't think so, because it has nothing to do with the query optimizer improvement. These are about the estimation, not about the processing itself. The batch execution mode is processing, not the building of the execution plan. Yeah. All right. So while it's running, I want to see the estimations. Ladies and gentlemen, we've got 13 row groups for 12.6 million rows. How many will we get? How many? Tell me the numbers, Brent.
It was how many rows?
12.6.
13 row groups?
Yes, the original one, the good one.
The good one. Oh, it's going to be different now?
Because I've set 20% of the memory.
Oh, memory. Oh, so we can only
5%. It's got not enough memory.
Oh, I didn't think that. Wow, that affects the size of your row groups too? Oh, man. Oh, that blows. Oh,
you know,
when
you don't see what I'm typing because I'm not typing.
Yeah. Oh, sure. Yeah. Evil assistant. Dang. So it depends on how much memory the box has.
So it's still running. It's 1,036,000 seconds. Should be actually around 1 minute. Most of the time, it's so evil that you will have no idea. So any estimations?
Oh, because I don't know how much memory the box has.
It has 8 gigs.
8 gigs, 2 gigs. I'm going to say like 50. I'm just guessing.
50. Okay. So any bigger numbers on the guesses?
No, nobody's guessed first. I don't think anybody else realized what's going on here either.
So.
Oh, wow. Geez, man, memory really does matter, huh? Wow. And I guess then it matters what other queries are running at the same time too, if you can't get enough of a memory grant.
I am rebuilding my Columnstore indexes. Who cares?
Yeah.
People who care on the next day.
Wow. So then it makes select queries slower.
So if I ran, for example, the details function, which will show me the row groups, you can see that it's copying on the total rows.
But on the bright side, they now fit on a floppy disk. So that's kind of cool. Yeah.
Some of them. The first one will not. I'm sorry. If you're not old enough, don't care. Floppy disks, they don't exist. Like Clippy never existed.
Wow.
So scary, really scary stuff. Don't try this at home. All right. So I spent half of the presentation. It's okay. I'm rebuilding. I'm bringing back the good old solution, right? So let's run it. Okay. The other thing is evil. Is you can see this demo. This is creating a C4 with a character 800. This one, no matter, so if I'm doing here with the regular user, not with the Niko flow, this will cut me. I will not run this demo because it will take me 2 minutes. It will get me to, maybe I can actually, maybe I last demo test I did, so you'll see the result. It was 65,000. Okay, of course. Now it's competing for the resources. So learn with Niko. Don't run the parallel with the other stuff. Bad idea. Bad Niko.
There's a question from iJeb. He says, "What about? Does it get any better in 2017 if you do things like off-row data? Are you allowed to do off-row data in a column store?"
Yeah. So you get we finally get the lobs on the cluster with Columnstore in 2017.
You don't sound excited.
Limits, the limits are still applied because this is the true part of in-memory. You need to keep the whole row group in memory fitted. If you don't have for the memory grant of the row group, it will be cut automatically. Lower the number, of course, half the memory grant until it fits, or until it might be, by rebuild will simply get you some deadlock and throw you out. Everything is possible. Okay, so there is something wrong with my virtual machine again. I can see. That's beautiful because it's running too slow. and still enough memory. It's 135, so let's hope that it will come back, because it's this is one of the bad things on the Columnstore. You can while you're doing a rebuild, you cannot run the DMVs information on you can't get the information on the DMVs. It's it will be, but you can see. So this C4 column 800, it will be cut to these two ribbons, ladies and gentlemen. And I'll tell you a secret, a little secret. There is nothing you can do about this at all. If you get big strings, you're doomed. They will be cut.
Wow.
Bad thing. Okay.
Wow.
Avoid strings. I won't. Yeah. All right.
Wow.
Okay. Then, oh, it's strings time. It will get even crazier, ladies and gentlemen. So I will be using the TPCH. You'll get the restore. Once you generate it, you can use the different 1 gigabyte, 10, 100 gigabytes, whatever you wish. For the restore, I create from the original line item table, line item CCI with the clustered Columnstore Index. And I will do something about one of the most problematic structures there. The line item table in the TPCH has a little problem. It's a fact table, or kind of a fact table. I'm not a very big fan of this schema, but well, I'm using it. Originally, it has a ship mode column, which is char 10. Char 10. Oh. So I said, let's see the distinct values within this column with our table, and maybe we can put them into the dimensional separate table, and by querying, we'll create a view and basically join them and see if it might bring us something, right? Okay, so line item CCI, test query to see how many, Niko, get the right database. We've got 7 distinct values. If this would be millions, not a good idea to put in a separate table. In our case, 7 distinct values, I'm fine. This will be a short lookup, a basic optimization, all right? So from number 3, we're going to the 4. We create the line item CCI optimized table, where we basically substitute L for the line item underscore ship mode into line item ship mode new, which will be a tiny int. I know you should be putting big int. This is a data.
No. Yeah.
I'm bad person. Okay. Clustered column store on it. You gotta put a column store on it, and then I'm like Brent. I love the idea of your presentation of you gotta put a key on it. That's beautiful.
Right? Yeah. Once you start singing, that's the end of it. Yeah.
Bad idea. So
all the single tables.
This is a professional broadcast.
I'm not so sure.
I would like to thank my parents for giving me such a I'll never see this video, but at least I'll try to do. So our dimensional table, we put in the unknown member, so we'll have the 8 rows. 8. They're loading the data, doing the lookup, building the foreign key. Please put a key on it. That's so many things. SQL Server is so intelligent unless you make it act stupid. And then I'll run it to queries. The first one, the 3 aggregates on the line item CCI, and the same 3 aggregates on the line item CCI optimized, doing a lookup on the ship mode. Okay, so no execution plan showing right now, because the whole idea is basically if you are putting the execution match showing in SSMS, your last query will get a bonus to it. And if they're very fast, this might be like triple the time of the execution bonus. So view the execution, then view the execution plan. Do not mix them. Very important. So this is something wrong, but 16 seconds. No, something is wrong because it should be actually the half of this time, the regular execution. Maybe I did something.
There was a guy who told me to check no matter what, check the compatibility mode. That's what I would say.
No, that's fine. This one was checked. I was doing something bad with MaxQP recently. I was like, maybe I did something really, really bad. I'll do cost threshold for parallelism.
Oh, there you go. There you go.
Well, let's do it the right way as much as possible. But the result you see, it's 2 times faster. The lookup, the second query, 8 seconds. The first one, 16. Okay. So this technique is basic. In a real data warehouse, in existing fact table, you might not be able to redesign it. But if it's critical, you might get some conversation started. So it might be very significant. So this one will basically show you in 2016 that we get no row group elimination here on this query. The set statistics IO here.
Woo!
We have different values for this L command, and this would filter the row groups like you do, but strings still do not support row group elimination. Please upvote the connect item for allowing this. Even for the default collation, we needed to get it started. Strings are so common. If you're running analysis services with a direct query, you just, there is no nothing else but strings, just suffering.
Wow.
Okay. There are other demos. I'll just stroll through it. So delta stores. If your data is not compressed, a string predicate push down will not work on the delta stores. And I have a demo here comparing with the row store table. Row store will function faster. So bad it will be. Okay. It's rare to get these occasions, but these are the limitations. And you can use the extended events and the demo scripts. And you can find on my blog the detailed information to see which single instruction, multiple data, synced instructions are being pushed or not. The message here, if you have got a lot of dictionary entries, more exactly more than 65,000, you will not get string predicate pushed down on this column.
And it sounds like this is a big part of the Columnstore work, is figuring out why the queries aren't going as fast as you want them to, and then it takes a new set of instrumentation skills. So now I'm seeing really why you wrote those scripts that you did to see deeper into Columnstore indexes, because you have to figure that stuff out yourself.
And there will be, so let me announce, there are new things coming for the library. I don't know, this will take place, I will finish them after TugaIT, so during the summer, I'll bring them. The whole idea is here basically all the knowledge that I've joined over the years to give you a possibility to go through this and other not published also practices and give you an idea, why is it slow? Just check this. This item is probably slowing you down to automate this work, to make you concentrate on the really important stuff, on redesigning this and whatever.
Wow.
Not like, you know.
Very cool.
Okay. So we're half the presentation, or maybe 40 minutes, and we're number 4 out of 15. Woohoo! So partitioning. So I created the line item table. I create the same orders table, and then I'll do something really crazy. I create a partitioning function, which is called fn_daily partition. I'll take my line item table and I'll partition it daily because I'm crazy.
Ooh.
Because I can.
Well, if you have 3 days worth of data, yo.
No, a couple of years.
That could be bad.
A couple of years. Oh, that will be bad. And I also create the monthly partitioning. So this one is a monthly partitioning. Here I'm doing, I'm creating a function which will, let me just show you, create a monthly partition. Between 92 and 99. Of course, I need to fit all. So you can see 1st of January, 1st of February. So the result will be, I will have 3 tables. Line items underscore CCI, non-partitioned. Line item CCI part. This is a partitioned, a daily partitioned one. Daily. And then the underscore months, this is the monthly. Okay, let's run it. Basic aggregation, nothing spectacular. I'll run it a couple of times because it's always a good idea. So first one, 20 milliseconds, as expected. The second one is 30 times slower.
Because of all the daily partitions.
Every single partition is a separate Columnstore index, which you can sort, and you should, on a different way. But it also contains all the dictionaries, deleted buffer, whatever, deleted bitmap, all those structures, all those internal tables. It will kill the performance. These same tables, 30 times slower because of the partitioning. Look at the monthly. When we go from daily to monthly, look at the result. That's 30 times less partition, and it's the same performance virtually.
Is there any guidance about like how many rows you should have per partition, or?
1,048,576. 1 million rows. This is on the SQL bits. Just I spent like 10 minutes. Most of answering the questions. Most of them were how big are the partition. I'm like, one full row group. It's not, maybe you'll be fine with 500,000 rows if you get like comparable performance, but make sure. So you can simply go into cstore_get row groups. I can't run it on this partition table because it will take half an hour or whatever. But on the other, it will just tell me. I need the details. So I can calculate 12.6 million rows. I have 13 row groups. Good numbers, all fine. And so all the library, you can go and say, like, show me one partition, show me an aggregate, whatever. Just read the docs if you interested. Drop Brent an email, he can answer.
No.
Hopefully. And Brent, do not forward it to me, please.
Give me the bad behavior horses email.
All right, sir, you asked for it. All right. So another test query, I took a PCH query, which is more like what you will see in real life. These are and exist and non-exist, not the best practices, but running the non-partitioned with the daily partition table, compare them. And what we will get is the performance will be very different. It's not 20 times, but still 1.5, 4.7 seconds. Just because of the partitioning. Just don't over partition. Keep your row groups tight, as close as possible to 1 million rows. And please send messages to Microsoft. Tell them we want to have opportunities to set them 2 million rows, maybe even like in analysis services up to 16 million rows. Might be a good idea. Scary because we will need more memory, right? Otherwise, we'll get the memory pressure because the row group need to fit into the memory. But this parameter is missing like for a good number of years since the first release, to be precise. Okay, using compression delay. Compression delay is basically a parameter. 2016 again, which is telling you that once the data is landing in the Columnstore index, and you can set it on all 3 column stores in 2016 and 17 on clustered column store, so data warehousing, on operational analytics or HTAP disk-based non-clustered updatable, or in-memory column store. It's basically a parameter in minutes. You can specify. So once data is landing into the Delta store, and Delta store has reached the maximum size with no other circumstances, it will stay like this after it's closed before being compressed into the compressed row group. So it's good because it's like if you have a hot data, you say like, I want that 1 day after data is landed to be still in the data store. I don't want, because it might be updated, and the compressed data, which is being updated, it's stored in the deleted bitmap. It's a logical fragmentation. 2014, the only solution is to rebuild the whole index, or using partitioning, just partition. It's nothing. You want these parameters to set sometimes, but if you're a consultant and you're landing, and you're just like, I don't know why it's not compressing. You know, you're using my library or check the DMVs, you see, aha, it's not compressed because somebody said it's like 24 hours delay. Okay. Copy paste from somebody else's script. Good idea. Not always. All right. So about identity, because we're running like not very slow. I'll stop at this second to take a breath, to show you once again the data monster. Any questions?
There is. Brad says, is it a bad thing if I create multiple partitions for the future that are just empty, or should I just only create them on demand as like I actually need to create those extra partitions?
The answer is you need to have at least one empty partition. So I'm hopefully next week, maybe in 2 weeks, I'll put a very big blog post I'm writing for a lot of time on the partitioning for the column store. There are a lot of small and not so small quirks on them. Huge topic, hugely important. Keep at least one empty partition always. So keep two, because like sometimes you just enter, oh, well, not what I wanted.
Gotcha.
Okay.
All right.
More questions?
No, that's it. Steph Locke is like, the 100+ articles that you've written are giving her a tough start. You know, she has so much stuff that she has to go read. But yes, keep going.
Book is coming soon.
Oh, are you actually going to do a book?
Yep.
Oh, good. Oh, cool. Very cool.
Wish I could announce on this show.
Oh, no.
I wanted to announce for earlier. Too many stuff. Let's get back to the real stuff.
Yes.
Okay. Blah, blah, blah. All right, so let's do the identity test. I'm creating here a staging table where I'm loading just 2 million rows. I'm creating a clustered Columnstore index on it, okay, on this script. Then I will create the fact online sales identity table, and I will load the data into it. And you will see that because I already have this table, if I truncate it, no, I don't, of course, because I reset this part of the demo, but I'm easily recreating this table in the script number 2. Yes, I am that chaotic, and I'm jumping around the different scripts. Just watch it time over time to find the right sequence. So sorry. No, not really. So if I insert the actual execution plan, because I didn't create the stage, well, trying to speed up stuff not always gets you the stuff you want to do. So I'm creating this staging table here with 2 million rows. I could have created it actually while I was talking. I decided to do it in a bad way, as always. So if I will include the actual execution plan, once this one is ready, should be like a couple of seconds, just 2 million rows, not hundreds. 20 seconds, we're done. If I run this query, because I selected, Brent is not here to help me, to tell me that I'm running on a different, on the wrong database. So if I run this query, you will see, even if I tried with tablock on 2016, it will not have the parallel insertion part. It's because identity is preventing it. And all these demos that you will find in the scripts, they will show you that you could try it with a sequence. You can do a lot of tricks, but you will not be able to get the improvements. And you can see even the reading of the data from the stage is single-threaded. There is no parallelism sign. And most importantly here, what I'm trying to achieve is the parallel insertion, because this would speed up. Trying with tablock would not help me in this case. So the solution is I have to say Thank you to Arvind from the SQL Cat team who tweeted me this solution. I was struggling to find, is to use this. I believe originally, if I'm mistaken, I'm sorry, but I believe Adam Mechanic was the one who introduced this solution. He's running the roll number over order by select now. And if I will run this one, I will get the best speed for insertion. So it took me 20, not 20, whatever. The most important part is the parallelism, and you should be able to see it. I'm running, of course, identity insert. And I hope the demo gods will be fair to me. And they're not, unfortunately, but you can see at least that I'm running the window aggregate in the batch execution mode. And I know why it's happening, that it's something else for the other demo. I'll need to reset it. It's the cost threshold for parallelism. In order for this demo to be fast, I need to, because the overall execution plan, no, it's 250. There is something else going on with my computer. I'm sorry for that, but you can run this on your computer. It should work correctly, and on my blog post you can read the details about this one. So identity, use this trick, roll number select over now. Another one, don't use merge. Just don't, ever. You can use the merge like this. Besides all the problems, and I'll direct you to Aaron Bertrand article. He blogged very good things. Some problems you can get into while using merge statement, and nobody cares or knows how to write the correct merge on the top of their head. Merge is basically delete and insert, because update is delete and insert for the Columnstore indexes. And so basically running the alternative of delete using with exists clause to make sure that you delete something that makes sense, and then inserting the data. I'll show you the difference. So this is the identity, but this is the merge. A huge difference on the merge and delete and insert. And it's the more data you're loading, if you're loading 500 million of rows, this will go absolutely not. Just Columnstore indexes, merge, avoid it. Because merge will not run in the batch execution mode, while your insertion can. You can get your insertion running in the parallel, in the batch execution mode, which will bring you a huge advantage. So for parallel data loading, and I see we're approaching, this is a very important item for the Columnstore indexes, especially. You will need to use a tab block. If you're loading the data in the data warehousing, not in OLTP scenario, use a tab block hint. This will basically split the workload between the number of cores. So if I'm loading, for example, 2 million rows and I have 4 cores on my VM, it will create 4 threads, each one with 500,000 rows, and it will not load them into the Delta store in a slow way. It will load the data into the compressed row group in parallel. So tab block hint is just hugely influential. It's 2016. Even if you're working with a row store, always use a tab block for data warehousing or BI. On OLTP, once again, very bad idea to load the data into your huge table that is running live with a tab block hint. Okay. I hope you agree, Brent. If you're not, well, then you don't.
I walked back and saw tab block and I went, whoa!
Woohoo!
Yeah.
It just runs faster. All right, so on the integration services, we're loading the data. Important things, important settings. So in 2016, you got one good setting, but you gotta have enough memory, because I've seen it crashing integration services service even. besides giving errors, which is a basic stuff. Oh, come on. My virtual machine doesn't like me. Testing connectivity. Yes, it's testing. Okay. So once it will be back, I hope I will be able to show it. But I'll show you the content which we will get. You will get SSIS, Visual Studio 2015 project, and you will get 4 files which you, for integration services projects, which you can basically run and test and see the results. Okay? Oh, come on. Yeah, so I didn't set it up because I'm trying to speed it up. Let me just solve this part. That's a Havoc, Niko. Professional Havoc. I need to do like a professional Havoc or
the Chaos Monkey.
The Chaos Monkey. I need this toy, Chaos Monkey. Okay. So let's put it on the right. Because of course, I put it on 2014. I have like 3 instances here on this virtual machine.
Just like production.
Data source. Oh, come on. I've seen one a lot of years ago.
Oh, yes.
32 gigs, 32 gigs virtual machine with 5 instances,
Yes.
each one having 6 gigs of RAM. And one of them will be running slow randomly. And everybody was wondering. And I'm like, well, I think we've got a winner. Like, let's lower the amount of memory. And you know what is wonderful? In the big companies, the answer was like, let's not. Let's solve the problem. I think they're still running that that virtual machine. One of the instances is solved. Why is it today?
Man,
We
I had
need the
one.
data science.
Yeah, one of them was I had a group of people come up to me and go, "Hey, you know what? Were you serious about in the presentation you just gave that you can have multiple databases on an instance?" And I went, "What?" And they said, "Well, yeah, you can have more than one database on an instance." And I said, "Yeah, why wouldn't you be able to do that?" And like, "Oh, all of our database servers, we have one database per instance because we didn't know you could have more than one." I just saved you. I just made your whole life much better. And they're like, "This is actually amazing." Like, okay, yeah. Very good.
All right. So you need to say the buffer size to 2 gigabytes and set the default buffer row size to the maximum size of the row group, which is 1,048,576, and set it to 100 megabytes, the maximum size of the buffer, of the data flow buffer. I'm sorry, but it just.
So this is so that SSIS puts in the right amount of data for exactly one row group and calls it a day.
Because the worst thing that happens is by default you are limited to 10 megs.
Oh wow! So it builds row groups at 10 megs in size, basically. Well, it doesn't. Okay, because yeah, it's small. That makes sense.
No, it just, you need to set a couple of the parameters. Take a look at the blog post I have on this integration services. Just these little things. So casting types. I love this one. Just let's run the same query. This one, receipt date is on the TPCH. I'm not doing the same mistake, hopefully. It's hopefully. I said it, not for real. So what is it named? Receipt date. Receipt date is a date. And I'm using a on this item string. It's not a date, because if I will show you the setup table, receipt date is a char 10.
Oh wow!
I'm not using a date. Okay. So if I'm using the default casting, or if I'm casting on the different side, so the difference, did I drop it? Let's say, did you drop it? Okay, let's run it. How many? Oh, I'll load all the data. Beautiful. Okay, it will take some time, but line item, because I know I edited the wrong demo while doing the test. because it's the same demo I ran at the beats, and I edited the beats with the changes.
Whoops.
I'll never learn. At least I will
Presenters.
correct this one here.
Presenter's life. Yeah.
Yeah. So it's running, and hopefully my. Come on, be a nice person. At least once. Okay, 100%. It's a typical situation. Columnstore, it's a hungry beast. It will eat all of what you throw in it. If you want to run something in parallel, create a workload group. Very important.
Wow.
Really, like, saves lives, as I have found out later.
Wow.
It's running.
Oh, Brad says he's got your alignment script, and he's got a partition on an integer, and he sees that it's not 100% aligned. What does not aligned mean?
Means alignment is you select one column, and you will. Sorry, the bells are ringing. Gotta go. Alignment means that for the integer data type and for the most data types, Columnstore indexes for each segment within the row group, it stores the minimum and the maximum value. So when the query is entering and starting processing, it gets this meta information and can say, oh, your predicate is saying I need values over 30, but this row group contains from 10 to 20. And my script does something that Columnstore Index still can't deliver, is sorting the data. Even though in 2016 there is an error message saying it's still not working. I don't know what it means, this error message, but maybe you'll find out soon, hopefully.
Right.
So I run these queries, one 4.3 seconds, the other one 2.5. Wait, why? I just did casting. If I take a look at the execution plans, this one is for all of you data warehousing people running like reports, whatever, or big processing. This one, and I'll do something bad I shouldn't be doing. And don't ask me what I'm doing. Hope it's not recorded, okay?
I'm sure we'll edit that part out in post.
Okay, so I'll accidentally save this script.
And these things just happen.
Okay, so you see I'm doing compute scalar. So the trace flag 8666, besides a lot of other things, don't ever run it in production, really. Not kidding. Because it shows you the statistics, all really cool stuff. But it shows me this one was missing in the original execution. Now it shows me I'm doing casting here on the first one for the Columnstore index, and I'm doing it with the batch execution mode, right? This one is blazingly fast, the casting of the data type. And I'm doing here also blazingly fast, but I'm doing this on the dimension. And
way shorter, way smaller.
Very smaller. But the result is the first one 3.5, 2.3. That is a winner. So if you are casting, if you are joining on not the same data types, I know it never happens to you, it happens to me, only to me all the time in my project. You let to SQL Server decide, that's cool. But just, understand. Maybe casting will just bring you to a different level of the performance. Another one is in null expressions. It just, I hope, I'm pushing it, I know. So I will run this query. I don't know if I have this table created, but I'm doing, like, I'm rocking. It's a Caval Maroto, for real. Not kidding. Bad orders, bad behaving for. So I'm doing here a predicate lookup on ship mode and the string, and I'm running isNow function. Do you see a predicate push down? No. Do you see a very bad filter saying just 9%?
Wow.
Yeah.
Wow.
Okay. If I will run on my row store table, the same one, this will take some time, but it's just about the concept.
Mm-hmm.
It's who wins where, it's another thing. Do you see the filter?
No, no. So it did the push down?
It did the push down.
Yeah,
You see the
yeah.
predicate.
Mm-hmm.
Okay. How can you solve this? So this one, this type, well, I see, let's say, I see a lot of these types of the predicates. Not now, yeah. Exactly, Brad design. So this one is the same table, rewriting with comparison and is now. And ladies and gentlemen, parallel running query, no filter at all. It's being pushed down the storage engine. Beautiful.
How'd you rewrite it? What'd you change about it?
So
You changed it to the or. Oh, you changed it to the or.
I changed it to the or. It's one of the limitations currently.
Okay.
I believe there is no changes in this sense in 2017 release, but there are some cool changes, little changes, like incredible stuff. Columnstore indexes. Let's say something important. They have a lot of bugs in this 2016 release. You know why? Because they did incredible job. I would say the best, for me personally, the best ever job. Going from one and a half architectures into three fully, completely implemented architectures. And I'm bowing down before all the teams that Georgi, Vasily, all the developers, Devin, everybody did incredible job. And 2017, there are some little queries, and I'll show you one today. One which is 2016 is running slow, and 2017 it's running fast, and just query optimizer. It's just the thing, they just tweaked it, and it really runs faster. Incredible stuff.
Vladi asks, does coalesce have the same problem that is null has?
Of course.
Yeah.
It's a now expression, right?
Mm-hmm.
It's not about is now. This is why even the demo is called now expressions. Okay. So query construction, there are a lot of things I wanted to show you. Don't use cross apply if you can. Sometimes you can rewrite cross apply, and you'll find on the web from much smarter people the example, some of the cross apply you can rewrite. Stop taking drugs, sir. Maybe not. The ones please, for the best of you and all of us, do it.
I'm even worse without them. Yeah, I'm even worse without them.
Just stacked overflow. So this one is running with a hash match. But there will be enough cross applies. In most cases, they will throw you into inner loop, and inner loop does not work, and it's not scalable really. So it probably will never work in the batch execution mode. So your queries will be slow. Bad things, bad people. Okay, cross applies, joins, and query construction. So check out these two queries. I'm doing the aggregation. I'm doing multiplication outside of the sum. And on the first, I'm doing multiplication on a constant within the sum. Let's run it a couple of times. Let's take a look at the result. The first one, 600 milliseconds. This is 60 million rows. This is not a bad table. Weird. What about the first one?
Wow.
Do you want to see the difference? So it's 4 times. It's just how I wrote the query, right?
Wow.
It's conceptually, it's 4 times the difference, right?
Wow.
And even worse. I burned just 4th of the CPU time as well. So let's take a look at the execution plan. Do you see the difference?
Yeah, the scalars moved. They do the scalar.
You know what? Kendra even posted about this. When you see actual number of rows, it's 0. It's because it's a full aggregation predicate being pushed down the storage engine. The blazingly, amazingly fast feature.
Wow.
It for the first query, when we put the constant into the sum, the SQL Server just, you know, query optimizer does miracles, but doesn't understand this one. And if we go into the properties, we'll basically see, of course it does, it's the best what it can, but it runs in the batch execution mode, but it's not getting this thing. And it does computer scalar, and it does run slow, and it does all the troubles. And here is the thing. Even though I never blogged about this, I have like 25 or 26 blog posts, work in progress. Jeez. This one, the first one on 2017, it runs like the second one for real.
Nice, good, wow. So they just probably rewrite the order of the math.
They did a better rule rewriting, and I'm like, guys, I'm just like,
yeah, that's pretty cool.
A lot of the things, smaller things, unless you find them, you just like, I don't know what they do. Maybe they sleep all the time. I hope they get some sleep. So wow. Georgievsky, Vasilis, Connor, of course, who is leading them, just like.
Pretty impressive. And because otherwise, if you have to tune between these two execution plans, it's really hard to understand exactly what's going on here.
My tool will help you.
Yeah.
Or these ones. He will say like, oh, you're not getting even though you have the aggregation, you do not get the aggregation push down. It's easy to recognize this pattern. So one of the things is like basically 130 compatibility level. Do you push something into the aggregation, which you shouldn't? The basic stuff, really, because you see the results are the same, and it does miracles. I need to finish because I need to pick up my kids. I'm sorry.
Go.
So the last one I wanted to show you is in estimated versus actual. So I created 2 test tables. There is one column which has a little difference, and I'll explain you what. But I'll run the query. So sample A, sample B on the Contosa Retail Data Warehouse database. You see, of course, I need to run the setup. And I need to roll just 2 million rows into them. In Brent, every time I do this, you need to say Niko, select the
right database.
The database. I could include it. I could have included the use statement, but I'm like, Niko, you're so smart.
This will never happen.
Bow. This will never happen to me. And it happens all the time. And now I'm on video.
Well, it happens to me usually when I'm in front of rooms full of people and they're like, you know, you're in the wrong database. I'm like, oh yeah, I just created a bunch of tables in master. Yeah, that'll do it.
I don't want to see my masters here. I don't want to see it. I don't care. I don't.
It's horrible.
That's so. Okay, so let's run this. Better. Estimate the execution plan for these 2 queries. Same. Look the same, right? I focus on one aspect, just the IO. If I see lob logical reads 11, lob logical reads 11. Woohoo! Tables are the same, right? Let's run. I'm just focusing on the statistics IO. Okay, so let's take a look. 365. Oh well, the second one has 367. Everything's fine. Yeah, close enough. Let's do another thing. Let's include let's give it to the users. 8 milliseconds, 148 milliseconds.
What was the difference between those 2? What are the 2 tables differences? Oh, A and B. Oh, there was A and B. I thought it was the same one at first. Oh, okay.
No. It's just like there is something with this column, man. Wait. Let's see the expected execution plan, estimated. Check it out. There is nothing you can find there. There is nothing in this estimated thing. Let's run the actual. If you really like it, you put an aggregate predicate push down on it.
That's exactly what Beyonce said.
Exactly, like respect, booyakasha, in the words of LEG. So it's the thing is, I'll show you the definition of the tables and then I'm gone, really gone. So the first table has a total cost numeric 18,3. The second one has a total cost numeric 19.3.
Wow. Yeah.
One. It doesn't really matter. It is. 18 occupies 8 bytes, and aggregate predicate pushdown works on 8 bytes as a max.
Wow.
Last week I was at the client and I was tuning them, and they had everything set to 36. And I'm like, guys, you need to lower your expectation. So 8 bytes is the limit for the aggregate predicate pushdown, and 18,3 versus 19,3 gives you the result. Aggregate pushdown working beautifully, 0 rows here floating, just the results will be coming out of the hash match. And here, this one is getting all 2 million. Imagine 20 billion rows. How beautiful will it be?
All from one data type. Wow.
Back to the roots, like if you are looking for the performance, and I'm not saying like, oh, you want to go faster and you don't care about the business. No, business is the first, but analyze, run. You should have or buy some software that does for you if you don't have your own scripts, or find some good scripts that do. Analyze your data types and see, what is you have defined and what you're really storing. Start the conversation with the business. Maybe there is something to discuss. And on this note, I shouldn't be doing this, but I want to show you, to say thank you very much to all of you. It will show, of course, the other one. Really, thank you. Great idea. No bullshit. Really, thank you for organizing this conference. I'm a fan here.
Oh, good. Thank you, sir. Thank you.
I'm trying to participate. I love that you are interacting with the people. This is really this is what I think this is what people really want.
Yeah. Well, they really want just the verbal questions and answers. They absolutely love that. So, yeah, everybody loves it. Thank you for volunteering your time, sir.
Absolutely. If you have questions, tweet to me. I promise that over the weekend, I'm sending you the script with the presentation. And if you send me an email, I'll do my best. I know there have been too many emails.
Oh, put your contacts on the next slide, right? Like your last, throw your info.
No, I see.
We'll go to the first one. There you go. There you go.
Of course, it will put it again. So there is no email. I know. I'm a bad person. I took it off.
They can get you from the blog. Yeah.
Exactly. You'll find me. I think it's possible. Thank you, Brent. Thank you, everybody.
Thank you, Niko. Thank you so much.